There is a special kind of silence that arrives when the world tilts toward night and the first stars appear. Not a silence of emptiness, but a silence full of distance. If you have ever stood outside and felt your worries shrink, not because they were unimportant, but because the sky gently insists on perspective, then you already know why humans have always looked upward with both fear and tenderness. Science did not take that wonder away. It gave it a steadier voice. In this story, we will move slowly the way good teachers move when a topic is large. We will define terms, honor uncertainty, and refuse to pretend that mystery is the same thing as guesswork. The universe is not a monster hiding in the dark. It is the stage, enormous, ancient, and surprisingly legible in places where our questions about life, meaning, and belonging must be asked with humility. So breathe, if you like. Let the narration be a calm companion. We are going to talk about how vast everything is, how the cosmos has changed across deep time, and what it really means when we ask, with hope and seriousness, whether we are alone. Let us begin with a simple fact that is also a kind of poetry. You are not floating in a vague outer space. You are on a planet, Earth, orbiting a star we call the Sun, which is one star among hundreds of billions in a flattened city of stars we call the Milky Way galaxy. That galaxy is itself one of many, like islands seen across an ocean too wide to cross in a human lifetime. This nested picture matters because it prevents a common mistake, imagining the universe as a flat map, with Earth at the edge of something. In modern cosmology, when we speak of the observable universe, we mean the sphere of space from which light has had time to reach us, since the universe became transparent enough for light to travel freely, a boundary set by cosmic history, not by a wall. The numbers can sound like fantasy, so we will not lean on them like weapons. We will use them as yardsticks. The point is not to memorize every zero. The point is to feel accurately that nearby in space is often unimaginably far in human terms, and that this truth is not meant to make you feel worthless. It is meant to make you feel precise about what neighbor means when the neighborhood is the cosmos. To speak about the universe without talking about light would be like speaking about oceans without water. Light travels astonishingly fast, fast enough that in everyday life it feels instantaneous. Yet in astronomy, light's finite speed becomes a ruler. When astronomers say a star is 4 light-years away, they mean that light, moving at about 300,000 kilometers every second, would need roughly 4 years to cross the gap between that star and us. A light-year is a distance, not a length of time, even though the word sounds like a clock. This is one of the friendliest tricks the universe plays on beginners. It turns time into distance, because the fastest messenger we know still takes time to deliver the news. When you look at the moon, you see it as it was about 1.25 seconds ago. When you look at the sun, you see it as it was about 8 minutes ago. When you look at distant stars, you are seeing old photographs written in photons. The past is not only beneath our feet in rock layers, it is above us in starlight. Once you accept that, the night sky becomes less like a ceiling and more like a library. Not every book is readable yet, but the shelves are real. Now let us anchor that ruler in something concrete. The Sun's nearest known stellar neighbor is the Alpha Centauri system, a little over 4 light-years away. One member of that system, Proxima Centauri, is a small red star with planets of intense scientific interest, not because science has proven aliens there, but because nearby exoplanets are precious laboratories for testing ideas about atmospheres, climates, and habitability. But notice what nearby means. 4 light-years is a whisper in galactic terms with the next-door neighbor, and yet it is an abyss for human travel as we know it today. If you could move as fast as today's fastest crewless space probes, think of the patient, decades-long pace of machines like the Voyagers. Crossing 1 light-year would still take many thousands of years. Multiply that by 4, and you are not planning a voyage. You are planning a story longer than recorded history. This is not an argument against exploration. It is an argument for honesty. The universe rewards telescopes before starships because light arrives for free if you build the instruments to catch it. And it rewards imagination, disciplined by mathematics, the kind of imagination that can feel awe without demanding science fiction endings. If we rewind the film of the universe, not like a movie with a studio behind it, but like a scientist rewinding a model supported by evidence, we find that the cosmos was hotter, denser, and more uniform. People often hear the phrase the Big Bang and picture an explosion in space, a bomb going off at a point. That image is misleading. What the evidence supports is closer to this. Space itself expanded, carrying matter and radiation with it, cooling as it grew. The name is unfortunate because it suggests noise and chaos in one corner of a room. The model is closer to the whole room stretching. We do not claim to know every detail of the very first instant with the same confidence we bring to later eras. Science is often strongest when it admits which sentences are well-tested and which are honest speculation. What is well-tested is that the universe has a measurable expansion, a predictable background glow from its early cooling, and a history of building structure from small beginnings. Those facts form a spine for everything else we will say. Expansion can feel like a betrayal of common sense, you might ask. Expanding into what? A helpful reply is that expansion is not about edges, it is about relationships. Galaxies, on average, move apart not because they are all rushing away from a single special point, but because the scale between them increases like dots drawn on a stretching rubber sheet. A common classroom analogy uses raisin bread. As the dough rises, each raisin sees other raisins drifting away, and no raisin is the true center of the expansion. Analogy is limp, but this one captures something important. You do not need an outside place for the universe to expand into in order for distances inside to grow. Observations of light from distant galaxies, stretched toward longer wavelengths, a phenomenon called redshift, match this picture in a way that has been tested again and again. The universe is not trying to confuse you. It is inviting you to upgrade your intuition gently, the way a student upgrades a first draft after better evidence arrives. One of the most beautiful pieces of evidence is also one of the quietest, the cosmic microwave background radiation. Long ago, the universe was hot enough to be ionized, a roiling plasma where light scattered constantly as if the cosmos were fogged in. As expansion cooled everything, atoms formed, the fog cleared, and light was set free. That light still exists, stretched by expansion into microwaves, not a sound, but sometimes described as a hiss in radio terms, coming from every direction. Think of it as a baby photo of the universe taken in light, showing tiny temperature differences that foreshadow where galaxies would later grow. When people say science can be spiritual without being supernatural, this is part of what they mean. A humble microwave antenna can listen to ancient light and turn it into knowledge. It is not magic, it is patience. If you read summaries of modern cosmology, you will meet two phrases that sound like placeholders: dark matter and dark energy. They are not excuses, they are names for patterns in the data, gravitational effects we measure, accelerated expansion we observe, that are not fully explained by the kinds of matter we understand best, like atoms and light. Dark matter seems to act like matter that clumps and pulls, helping galaxies form the way scaffolding helps builders move safely. Dark energy, in the simplest current picture, behaves like a smooth property of space associated with the universe's accelerated expansion in later cosmic history. The details may change as research continues, science is alive, but the emotional lesson is simple. The universe is not only what we can touch, it is what we can measure. And measurement at its best is a form of respect for reality as it is, not as we wish it to be. Stars are the universe's workshops. In their cores, nuclear fusion transforms lighter elements into heavier ones, releasing the light that makes life possible on a world like ours. We are not being poetic only for poetry's sake when we say we are made of star stuff. We are summarizing a physical lineage. Stars are born in cold clouds of gas and dust, collapse under gravity, ignite, live for timescales that depend on their mass, and eventually return material to space through winds and explosions, seeding the next generation. You do not need to memorize every stage to grasp the moral. The universe recycles, it is patient, it builds complexity in steps, and it does not require a human audience to keep working. which can feel lonely until you remember that you are here to witness a tiny slice of the process, and that witnessing is itself a kind of belonging. A galaxy is a gravitationally bound swarm of stars, gas, dust, and dark matter. A city, not a single building. The Milky Way is our home galaxy, a spiral whose arms contain nurseries where new stars still form. Other galaxies exist at immense distances, some colliding gently in long dramas, some quiet, some hosting central regions so extreme that they challenge intuition. Yet this video will not linger there, because galaxies can steal attention from the human-scale question we are circling. For now, treat them as context. The universe organizes itself into neighborhoods, and those neighborhoods are where stars make planets, and planets are where chemistry can become interesting. Galaxies are also a reminder that empty space is rarely empty in astronomy. It is a field: matter, light, magnetic fields, ripples, history. For a long time, humans could only count planets in one system, ours. Then, in the last generation, the census exploded. Using methods like the transit technique, watching a star dim slightly when a planet crosses its disk, and the radial velocity technique, measuring a star's wobble from a planet's gravity, astronomers have found thousands of worlds orbiting other stars. Some are giant and hot, hugging their stars in days. Some are small and rocky, though rocky does not automatically mean pleasant. The discovery of exoplanets did not prove aliens. It proved that planet-making is common enough to be observable. That shifts the mood of the question, are we alone? It does not answer it. It makes it more earnest, because the universe is not an empty stage. It is a crowded attic of possibilities, waiting for better instruments and careful thought. When people talk about a habitable zone, sometimes called the Goldilocks region, they usually mean the range of distances from a star where, under simplifying assumptions, a planet with the right kind of atmosphere could support liquid water on its surface. It is a useful starting line, not a certificate of life. Venus and Earth are a lesson in why distance from the star is not destiny. Worlds differ in atmosphere, geology, magnetic fields, and history. A habitable zone is a sketch of energy balance, a way to prioritize targets for telescopes. It is also a moral reminder. Life, if it exists elsewhere, may not advertise itself in ways we recognize. It might live in subsurface oceans, in ice shells, or in chemistries that do not mirror Earth perfectly. The habitable zone is therefore both hopeful and humbling, a map of where to look first, not a promise of what we will find. Modern astronomy searches with increasing sophistication, measuring the chemical fingerprints of starlight passing through a planet's atmosphere during a transit, hunting for biosignature gases that might, emphasis on might, be produced by life, studying magnetic environments and comparing planets to models of climate and geology. Each method has limits. False positives exist. Earth itself would be tricky to interpret from light years away if you did not already know what you were seeing. This is why good scientists speak in likelihoods, not theatrics. The search is not a race to announce aliens. It is a patient widening of evidence, a habit of mind that families can admire even when children ask impatient questions. The answer may take decades. The discipline is something we can practice today. In public conversations, life sometimes becomes a cartoon. Little green visitors, instant messages from the stars, movie villains. In biology and astrobiology, life is discussed as a set of processes: reproduction with variation, metabolism, boundaries, response, that can, in principle, leave physical traces. We do not have a perfect one-sentence definition that satisfies every philosopher, and that is fine. Science often works with workable definitions that can be refined. The important emotional point is that searching for life is not searching for entertainment. It is searching for kinship in chemistry, for the possibility that the universe's patience with complexity did not stop at one planet. Even the word alone changes meaning when you expand your circle to include other species on Earth. Loneliness is not only interstellar, it is also ecological. Science invites us to widen care without losing rigor. If life exists beyond Earth, our first detection might not be a radio hello. It might be a subtle atmospheric imbalance, a pattern in a spectrum, or a clue from a moon. In our own solar system, icy moons suggest subsurface oceans kept warm by tidal heating. A reminder that habitable is not only a zone around a star, it can be a zone beneath ice, where water touches rock and chemistry can churn. These possibilities do not guarantee microbes, let alone civilizations. They widen the search. They also teach empathy for unknown forms of life, not as monsters, but as natural phenomena that deserve careful language. A family listening to this deserves a narrator who will not turn mystery into fear. You may have heard of the Drake equation, a way to organize thinking about how many detectable civilizations might exist in our galaxy at a given time. It multiplies factors: star formation, planets, habitable worlds, the probability life arises, the probability intelligence arises, and so on. People sometimes mock it as guesswork dressed in algebra. A fairer view is that it is a map of our ignorance, and maps of ignorance are useful if they stop you from pretending you know what you do not. The equation's value is not that it produces a reliable number. Its value is that it forces separate questions to stay separate, so one hopeful assumption does not secretly infect everything else. Used humbly, it is a lesson in intellectual hygiene, something teachers can love. The Fermi paradox is often phrased as, if civilizations could be common, why do we not see obvious evidence of them? That question has many possible answers, and none should be shouted as final. Maybe technologically capable civilizations are rare. Maybe they exist but do not broadcast in ways we recognize. Maybe they are short-lived or careful or very far away or uninterested in us. Not as an insult, but as a fact of scale. Maybe some combinations of these. The paradox is less a proof of loneliness than a proof that our data set is still small. It is also an emotional mirror. Humans sometimes imagine the universe as a social network. The cosmos may simply not work that way. Wonder can survive that realization. Indeed, wonder can grow because the universe is not obligated to match our storytelling habits. SETI, the search for extraterrestrial intelligence, is often described as listening for radio signals. That is one slice of a broader idea, looking for techno-signatures, patterns that might indicate technology rather than biology alone. The work is difficult, underfunded in many eras, and ethically charged. A calm narrator should mention the care involved. Scientists think about misinterpretation, about hype, about what it means to announce a detection responsibly. Families should know that science at its best protects the public from its own excitement. If you are listening to this for sleep, hold that as a quiet comfort. The universe is not a jump scare. It is a long book, and we are early in the reading. Some thinkers emphasize how many coincidences seem to line up for a world like ours, a rare Earth-style argument. Others emphasize how enormous the numbers are, suggesting that even rare probabilities can happen often in a vast cosmos, a many worlds intuition. Good science does not demand that you pick a team like a sport. It demands that you weigh evidence and avoid certainty where certainty is not earned. You can feel emotionally moved by both perspectives, the preciousness of life if it is rare, and the possibility of kinship if it is common. Neither perspective gives anyone permission to be cruel on Earth. If anything, both perspectives ask for responsibility. To protect life here, to protect dark skies for science and wonder, and to speak about aliens without turning strangers into monsters. We began with silence and distance, and we end with a different silence, not the absence of answers, but the presence of questions held well. The universe is vast. The nearest stars are far beyond a human lifetime at familiar speeds. The cosmos expands and carries galaxies apart. Ancient light still whispers of younger times. Planets are common enough to surprise us. Life's existence here is a fact. Life's existence elsewhere is an open investigation. Are we alone? The honest scientific reply is we do not know yet. And we do not know yet is not a failure. It is an invitation to keep learning with dignity. If this narration has done its job, you feel smaller in scale but larger in responsibility. to care for the pale blue world we share, to teach children that uncertainty is not the enemy of wonder, and to look up at night with gratitude rather than fear. The story continues in telescopes and textbooks, in classrooms and quiet walks, in every person who decides that truth matters, gently, patiently, together.